Here we have another problem using electrophilic aromatic substitution reactions. What I want you to see is that we're starting for nitrobenzene, and we are doing the reactions in different order. And so let's see what the outcome is. If you see what is on this side, we're going to be doing a reduction of the nitro group, and then we're going to be doing a bromination to see what happens. Here, you're inverting those steps. You're doing a bromination first, and then you're doing the reduction of the nitro group. And here you have more steps. Here you have reduction, sulfonation. Why? Let's see, how is that? And what is the outcome of the three different pathways? So essentially, same reagents, but we're changing the order in which we're doing things. So let's analyze this side first. Here you have the nitro group, deactivating, meta-directing. And but now the first reaction is what? We're doing a reduction. So your first product, we're going to be writing here, is the aniline, but here we need to actually, after the reduction, we need to add NaOH to recover the free amine. Right, but this is your first product. And what now? We have a bromination step. So when you do the bromination now, analyze what is here. The functional group has changed. Nitro group is deactivating, meta-directing, but now we have the amino group, and this is activating, ortho-para-directing. So after you do the bromination, so step 2, you will have the ortho and the para bromoaniline. So ortho, bromoaniline, and the para. So these two products. And now, let's compare what happens if I invert the sequence in which I'm doing the reactions. So nitro group is deactivating, meta-directing, and I am doing a bromination, so installing a bromine. So after reaction 1, you get the following product. Let's say, okay. So let's do reaction 1. You first obtain the brominated, but where? You're going to put it in meta because it is meta-directing, but this is not going to stay there. You have a second step. What is that step doing? Reducing the nitro to an amino. So the final, so this is just step 1. Step 2, you are reducing the nitro group to the amino. So notice that here you have your product is meta-bromoaniline. This is ortho and para bromoaniline. So meta. And here you have ortho and para. So notice that because you have changed the functional group here, the radio selectivity, the orientation where the substitution occur has changed. So this is ortho and this is para. And likely I'm going to have a mix of the two. So to avoid that, we're going to add another step. Let's see what happens now if I follow the sequence on this side. So I'm going to draw here after, if I do nitrobenzene and do reaction 1, that will be similar to that, right? So we're doing the reduction of the nitro to the amino. So let's just do the amino group here. Now you have aniline. Aniline, this group is activating, ortho-para directing. What is this reagent here? This is concentrated, let's do this, concentrated sulfuric acid, fuming actually. Let's write that better. Let's say fuming means it's concentrated and saturated with SO3 gas. So fuming, you can say probably in a problem just HSO4 fuming, and that means it has SO3, and that's your electrophile. So you're installing a sulfonic acid group in reaction 2. So reaction 1, you did the reduction. Reaction 2, you are sulfonating. Where? Group is activating, ortho, para, directing. Now, sulfonic acid group is large, so the preferred position is going to be the para. So now you're going to have SO3H at the para position. And it depends. Okay. What we're doing here is actually protecting the para position. Remember that in synthesis, installing a sulfonic group is very useful because we can install it, do some other chemistry steps, and then we can remove it. This is what we're doing here. Now we're protecting the para position. Notice that in step 3, you're doing the bromination. Now where to? You have here activating group, the amino. The activating group. The activating group is going to determine the location, is ortho-para directing. The para to the amino is occupied, so it's going to be ortho to the amino group. So your product after reaction 3 is going to be the following. So this is your sulfonic acid in para, your amino, and now you're going to have bromine or to the amino. Either of the two positions are identical, right? Okay, and so what's in step 4? The step 4 here is diluted sulfuric acid and heat. This is to desulfonate. This reaction is reversible, so installing a sulfonic group, this you install, this you remove. So we use this group as a protective group. We're protecting the para position. Now using condition 4, I'm going to remove the sulfonic group. And let's see what the outcome is. So I have amino here. And I have exclusively, after removing this, I have exclusively the ortho bromoaniline. So now let's analyze what happened with the 3 pathways, changing the order of the reagents. If we did the reduction of the nitro first, here, aniline, and do the bromination, we're going to have a mix of products, ortho and para. So 2 products, not very clean. If you do the other order, inverting those 2, the nitro group is deactivating, so you're going to have the bromination in meta. Final product is meta-bromoaniline. But we can get the para if the ortho exclusively if we protect the para position, which is shown in this strategy. So first, the reduction of the nitro group to the amino, then the amino group is activating, ortho-para directing. This is large, so it's going to be installed in the para position. Now this is protected, and you do the bromination in the step 3, and it's being forced to go here because the para position is occupied, and then you desulfonate. So this strategy allows you to get obtain exclusively the ortho bromoaniline. Okay, so it is important that the order in which we do this reaction. This will help you plan synthesis.